In this lecture, we'll explore the transformer architecture and understand how it generates text step by step. Imagine you ask a transformer-based model like ChatGPT to write an email apologizing to Sarah for a tragic ending and explaining what happened. The model processes your request and begins generating the response one token at a time. For instance, if you're using a GPT-style model, it takes the entire input, predicts the first word, then uses that output along with the previous context to predict the next one. This process continues word by word until the full response is complete. Now, let's look at what happens inside the transformer. The input text first goes through a tokenizer, which breaks it into smaller units called tokens. These tokens are then converted into token embeddings, which represent each piece of text as numerical data the model can understand. Next, these embeddings move through multiple transformer blocks, layers that perform complex operations such as self-attention and multi-head attention. In the original transformer architecture, there were 6 of these blocks, but modern models may have many more. After passing through the transformer layers, the processed data reaches the language modeling head. This part of the model predicts the most likely next token based on probabilities. If the temperature setting is 0, the model follows a greedy approach, choosing the token with the highest probability every time. When the temperature is set higher than 0, it introduces randomness, allowing the model to pick from several high probability options, which makes the output more creative. For example, if the model predicts title as the first word, it might begin by generating the subject of the email before continuing with the rest of the content. One of the greatest strengths of the transformer architecture is its ability to process input data in parallel. This parallelization allows it to analyze entire sequences efficiently before predicting the next token. Once the model has computed contextual embeddings for the input, it doesn't need to recalculate them. Instead, it reuses stored values known as cached embeddings to predict subsequent words more quickly. To summarize, the transformer workflow begins with text input, which is tokenized and embedded into numerical form. These embeddings pass through a stack of transformer layers, followed by the language model head, which generates the output one token at a time. Depending on whether the model uses an encoder, decoder, or both, the number of layers can vary. Ultimately, each predicted token builds upon the previous ones until the final output is produced. I hope this explanation helped you understand how the transformer architecture processes and generates text efficiently.